Okay. This lecture is going to be involved. There's not anything new to deal with here. What we are doing is taking many of the items we've already worked with and putting them together to answer questions. Okay? How far is it from? Well, if we're not given two exact points, we can't just use the distance formula. Okay? This is what we're looking at. You need to read Chapter 2, Section 10 notes. Okay? That's in your files already. The tools you're going to need to pull together, okay, it's just like you're doing a job around the house, you need a specific set of tools. We're going to need to be able to figure out what a slope is, okay? We're going to need to know what parallel slopes are, what perpendicular slopes are. We're going to have to remember the distance formula. We're going to have to remember the y-intercept form, the linear equation, and also the point slope form. Okay? The two types of questions you're going to deal with are, okay, find the distance between a line and a point. Find the distance between two parallel lines. Now, if the two parallel lines are both vertical, you just can count. If the two parallel lines are horizontal, you can just count. Okay? Rest assured, that's only going to be one question, a nice easy one. Here, solve this. Okay? This is what we have to deal with. I'm going to give you this picture, of course, but these are the steps. Okay? I'm going to go through each of these steps to solve these problems over here. There's two problems. I've got one where we are going to find the distance between two lines. They happen to be parallel. And then we've got a question where we've got to find the distance from a line to a point that's not on the line. Okay? And it involves finding equations, okay, finding the y-intercept where it's crossing the y-axis, okay, the equation of the other line, the one that's perpendicular. Yes, we're going to have to go back to algebra and solve systems of equations, either addition, subtraction, or substitution. Okay? We're going to use the distance formula to deal between those points. Then between parallel lines, which we're going to start with here, we're going to start with an equation of a line perpendicular to both of these. Okay? Kind of creating a railroad track. We're going to use a system of equations for these two equations to find the points of intersection and then the distance formula. Okay? Yeah, you're getting pictures of this. Okay? Here we go. I have started with this. Okay? Okay, there's that. I'm going to turn the lights off and see if this works. I have no idea. Hey, you can see okay with that. Okay, here we go. Yeah. I wrote these down and did them myself. Okay? They're involved problems. That's why you're not going to get a ton of problems for your assignment. Okay? These problems are going to take you a few minutes to do. So here we go. Find the distance between line D, which I've made dark red, and E, which is the dark blue. Okay? On this particular case, this is all you're going to be given on the worksheet for the problem. Okay? So, the first step I take, even if it's just to sketch it out on scratch paper, I want to see what these look like. I want to see where points are. I want to be able to visualize it. Okay? My first step, I'm going to find the slope of each line. Okay? So, the slope of these, since they're parallel, it's going to be the same. Okay? My slopes is -1. That's given to me right there. Now, the slope of any line that is perpendicular to that, because in order to find the distance between something, we use perpendicular lines. Sneaky, huh? Okay, so perpendicular to -1, the slope would be a +1. Okay, so that's where we're at right now. Okay, so step 1, we are going to draw a line. I'm going to draw a line perpendicular to these right here, just like I did right there. And I'm going to take it through that point because that's where it's crossing through the y-axis. Okay? So, stay. I'm going to use this. 1. Stop falling. Okay. Okay, we know the slope is a +1, so I just went up 1 over 1, up 1 over 1, and I'm going to do this. Okay? We know it's perpendicular because its slope is the negative reciprocal of each of these. Okay, so there's my first step. Okay, next I'm going to find the equation of this line. Okay, I know this point right here is 1, 2, 3, 4, 0. Okay, so I'm going to plug that in. And this is line F right here. And we're going to substitute in. Okay, and that was the dark blue over there. I'm trying to keep these as color-coded as possible. Okay, slope is 1. Okay, I'm going to clean this up a little bit. Okay, so there's the equation of the light blue line right there. Okay? Now, I want to find the intersection of line F and line D. Okay, I already know this point right here. If I can find this intersection, I will have 2 points to find a distance from, or between. Okay, so here we go. Okay, we know that line D is that. Okay, and we know that that is line F right there. Now we do have to remember how to solve systems of equations. Okay? There is the substitution method. Since I know what y equals, I can replace it and solve it that way. That's one very good way. We can add, subtract. That's the other way. Okay, those are the two best ways. Either way you do it, okay, you're going to get, see right there, x and y. So I just added them down. Nothing big, nothing crazy here. Okay. 2y, the x's go away, negative 4 comes down, divide. So I've got y equals negative 2. I'm going to substitute back in, okay? I really need a clipboard of some kind here. Since negative 2 equals negative x, x is equal to 2. Yes, those are my knees. So our point of intersection okay, 1, 2, 1, 2, right there. So that's our other point. So what we are going to do right now is find the distance. Okay? So we're going to find the distance between those 2 points. There and there. That's the distance between parallel lines right there. That's what we're finding. Okay? So here we go. Distance is 2 minus, did I go that way? Yep. Okay, so there we go. We're going to clean this up a little bit. Okay, 2 minus 2 gives me 2. Negative 2 plus 4 gives me 2. 4 plus 4 is 8. The square root of 8, plug into your calculator. Approximately 2.8. That is this right here. And since they're parallel, everywhere between those 2 lines is also about 2.8. Okay, there's our first one. It's difficult at first because you haven't put all of these steps together. You have been told, find the distance between these 2 points. You've been given the points. You've been told, hey, you've got to find this equation. You've been given the points, okay? Now we have to start putting things together. This is problem solving. Okay, this is critical thinking. What does it take to get the answer I need? Okay, in this one. Okay, more work, see? Okay, on this particular problem, I'm cheating. I've got a holder. Ha-ha. Okay. First things first, we want to find the distance from line G, which They are giving us 2 points that are on the line, okay, to a point P with coordinates 5, 1. Yet again, I want to visualize, so I am drawing this. Okay? So this is line G. Here are the 2 points, there and there. Here is point P. This is what we are going to have to find, that distance right there. Now, we don't necessarily know what that number is right now. Okay? But we're going to find it. I had to get a slightly brighter color. This is the distance we're trying to find right here. I looked down and saw that you couldn't see that at all. Okay, so that's what we're looking for. So the first thing we're going to have to do is find the equation of line G. Well, the first thing we've got to do there is find its slope. Okay, so the points we're going to use, okay, are right there. Okay, x1, y1, x2, y2. Okay, so the slope of our line is right there. Okay, that's the first thing we have to do. The second thing we have to do is turn it into an equation. Okay? Okay, for that we're going to use this point right here. Okay? Because it's got a 0 in it. Okay? Y minus 0 is just y. 4/3 has to distribute. Remember, minus the negative is plus. So 4/3 times 2, tops multiply, and then 3 times the denominator. So this is my equation of the line. Okay? Now I have to find the y-intercept. Once again, using -2, 0, okay, y, x, okay, so we're good there. Oh, plus b, sorry. Silly me. Okay. That's what we're looking for. We want to see where it's crossing the axis. So we've got that. We know this is 4/3. This is -2. Okay, I got all my numbers there. Okay, that's where it crosses the y-axis, which is right about here. Okay, and that's absolutely correct. There's 3, there's 2. 8/3 is about 2 2/3. That's where it's supposed to be. Okay, so now we've got our y-intercept. Now we want to find the equation of the line that is perpendicular to G. That's this one right here. So that's the equation of the line. Okay? So we know its slope has to be the negative reciprocal of this. Okay? Negative reciprocal of that. So we're going to start with its slope. Okay, so there's our slope there. Okay. Then we're going to figure out the equation for that line, and we'll go with the point slope form again. And this is okay, just so you know, this point is the one I'm using right here, okay? 5, 1. Remember the point slope form, we have to substitute the x and the y, okay? I'll walk you through my next step here. Okay? I multiplied throughout, distributed. Okay? So, negative times positive is negative. Negative times negative is positive. 3 times 5 is 15. When I move this 1 over here, throughout this problem, we got to remember common denominators. So, if I add 1 to both sides, I'm going to do it in this form. 4 over 4. Okay, so now I can combine. That's the equation of that line. Okay? So, our next step. We are going to find the intersection. And we are going to find the intersection of this line and of this line. And once again, that's the addition subtraction. Okay? Come with me a little more down this way because we need some board space. It's okay, we're right about here on the paper, almost done. Okay? So, we have our fifth step. Let's see. Okay. Okay, you're looking at that and you're thinking to yourself, I'm going to run through the wall. Okay? I added, subtracted, you can substitute, okay, whichever way you want to attack it. The first thing I did, I told you about it over there, the first thing I did was turn these four fractions into fractions with common denominators. It will make life much easier for you. Watch. Okay? If I turn this one here, okay, the blue one, I'm going to realize that the common denominator for the 3 and the 4 has to be 12. Okay, 16 twelfths and 32 twelfths. I did the same thing with the orange line. Okay, whoops. Okay, now, when we add that, we can't add because you get 2y, so I like to subtract. That's just personal, gone. Minus and negative becomes positive. Okay, and then over there we're going to do the same thing, subtract. I hope you're seeing this is going to be very clean in a second. I'm going to add that to both sides of the equation. Divide both sides by 25 twelfths. Okay, and now we're going to substitute back in. Okay, I'm just going to use the blue one. It's right there and it's easy. Okay. Okay. 4 thirds, 8 thirds gives me 12 thirds. Y is 4. Okay, so my ordered pair is 1 4. Okay. that point right there. And we already know this point right here is 5, 1. So now I have the 2 points to find the distance between. Okay, I found the intersection. Okay, let's call that intersection. It's easier for us to remember. Okay, I prefer that. And our last step is the distance formula, okay? And we have our points. Make this our distance. Rather than making it one step, I'm going to create 2 out of it. When I did this myself, I turned this into one big step. We don't want to do that. We'll make this 2 separate steps for you. Okay, so we've got distance now. Okay, our first point is the point 5, 1. That's the one that was given to us in the problem. And then the one we just found here, okay, the point 1, 4. And we're going to find our distance between these points. Okay, once again, distance formula. Okay, once we get this one, with the magic of modern technology squaring numbers, we get the positives. 16 and 9 is 25, and the square of 25 is 5. So we did all of this work to find how far it was from that point to that point. Okay? Yes. As I said before, this is a long, involved process, but it's not a difficult process because you already know this. There's nothing new here for you. It's just putting things in order to make them work for you. Okay, that's what you're dealing with. Okay, yeah, I know during class we're going to be doing some more examples of this as we work our way through. I'm going to take the pictures right now, so you're going to have them to work from. Okay? Okay, don't fret, relax, look through it, look through the notes, okay? Look through the board photos once they pop up, okay? So we're good. And like I said, there's only going to be a few problems to do with these, so don't worry about that. Okay? I'll talk to you soon.